Okay, we've just reviewed the synthetic substitution method in that process. Now we're going to see how that's going to help us with polynomial division. Okay, and so the first thing that you need to realize is that the synthetic substitution process actually gives us the coefficients of a quotient, and what that means is that when we divide something, a polynomial, by another polynomial, we get a quotient, we get the answer. Okay, well, synthetic substitution actually will give us the answer to the division problem, and so we can call it synthetic division. The thing here that you got to keep in mind, though, which can be kind of confusing at first, is it has to be in the form of x minus k. Now, I'm going to go over that here in just a second. So if x minus k equals 0, then that's just like evaluating an expression for x equals to k. So it's like k is the part that we use for synthetic substitution, which in essence is the same thing as synthetic division. You should know the synthetic substitution process, but let's see how the answer differs a little bit here. We're going to use the same old problem that we've been using, x squared plus 4x plus 4 divided by x plus 2. Now we should know that the answer at this point is going to be x plus 2. We know that that's going to be the answer, but let's just assume we didn't. So if we wanted to use polynomial long division, we'd have to set up the whole long division thing, and as you probably felt in previous part of the notes, that was not the easiest method. So what we're going to do here is we're going to take this x plus 2, and if we assume that it was equal to 0, basically what we're saying is that the x equal, we're going to evaluate this expression for x equaling to negative 2, and so that x equaling negative 2, there's that value right there. And of course I'm going to just drop in the coefficients, so 1, 4, and 4, and I'm going to go through this process of synthetic substitution. But the difference is, when we get our answer, we have these string of values, 1, 2, and 0. When we evaluate x at negative 2 and we get a 0, that means we have a factor, or we have a intercept. So we have a perfect remainder of 0. What you got to realize, however, is that this string of numbers also gives us our coefficients to the answer, or to the quotient. And so in this case, if we were dividing by an x squared, we were technically pulling out or factoring out 1x. So now we're to x plus 2 with the remainder of 0. And so that shows us our answer using synthetic division. Now, it's a little awkward at first, but once you do this a couple times, and the synthetic substitution process ought to be pretty easy for you now, I think you'll realize that synthetic division is much preferred to polynomial long division. So let's just see how this works out. Sample problem 3. It says use synthetic division to divide the following polynomials. Go ahead and pause the video at this point and try to set this up and see if you can come up with the correct answer. Okay, so we're going to just pull the coefficients out of the polynomial. So that's a 1, a negative 3, a negative 7, and a 6. Notice there were no gaps in our string. Now we need to know what to put out here. Well, I can simply make this equal to 0 and solve for x, and that shows me x, we're going to evaluate this at x equals negative 2. So that's what we're going to do. So we're going to drop the 1 down. 1 times negative 2 is negative 2. We're going to combine like terms. Gives us negative 5. Negative 5 times negative 2 is a positive 10. We'll combine like terms. That gives us 3. And 3 times negative 2 gives us negative 6. And we combine like terms for a 0. Now, what happens here is this. We need to know, when we divided this polynomial by x plus 2, what was our remaining polynomial. And so this last number is always going to represent the remainder, and the other part is going to represent our quotient. It's going to represent the polynomial that we had. So since we started with x to the third, that means this is going to be x to the second, this is going to be x, and then the last one doesn't have a variable. So our answer is x squared minus 5x plus 3 is our final answer. Now, if we did this as a fact family, what we could say is this. We could say that x plus 2 times x squared minus 5x plus 3. When you multiply those together, you should come up with x to the third minus 3x squared minus 7x plus 6. And so you could go through the distributive process and confirm that. So basically we have a fact family here. Two factors that multiply together to get a larger polynomial. If we wanted to divide it by either factor, we could use polynomial long division, or we could use the synthetic division. Now, we were very fortunate in this case that we had a remainder equal to 0. That's not always going to be the case, and sometimes we're going to have to deal with a remainder and writing that in the correct method. That being said, let's go to our next sample problem. So you can see we've got the same polynomial that we're dividing by, except we're dividing by a different factor, one that probably doesn't go into it evenly. So go ahead and pause the video at this point and see if you can work this through synthetic division. Okay, if we just drop the polynomial coefficients down into our box again, and then this time we have x minus 4 equals to 0, so we're going to evaluate this function at a positive 4, and so we'll drop this down. 1 times 4 is 4. Combine like terms, which is going to give us another 1. 1 times 4 is 4. We combine like terms, we get a negative 3. Negative 3 times 4 is negative 12. And so when we combine like terms, we end up with a negative 6. Now, let's rewrite this as an answer. Remember, this last value is always representing our remainder. So that's a remainder of negative 6. Since we were starting with x to the third and we were dividing out or factoring out one of them, that means the first number in our string represents the squared term plus the single term minus 3, but this time we have a remainder of 6. So that's going to require us to write our answer in a proper form. So let's take a look at how that should be written. We don't have to write ones because those are understood. So we've got x squared plus x minus 3. Now we can do this one of two ways. We can say plus a negative 6 divided by, and remember we were dividing by x, if you recall there, we were dividing by x minus 4. So that's important because we're going to divide the remaining part that we have left over by the same value that we divided the original polynomial. So that's one way that you could write this. If you didn't want to have double signs, plus minus, you could also write this as x squared plus x minus 3 minus, and then it would just simply be a 6 over x minus 4. So this is how we need to write a remainder. So very important that you understand how to write the remainder of a polynomial in your answer. Okay, since it's not dividing in there evenly or it's not a perfect factor of it, we're going to have to write our remainder. Alright, and so hopefully after a few problems you start to recognize that synthetic division has some value here so that we don't have to take on polynomial long division.